coming. If you guys could give me a nice big round of applause for Bryan McLellan.
All right, this is the general agenda. We'll work through a bunch of stuff. Chef's a really big topic, so I'm going to go through a bit of an overview of it. We'll talk about why you should be using Chef, and I'll show you the Nagios cookbook that we have in our community and how it works with Chef and how it's pretty slick. I was one of the original Chef developers. That was 5 years ago now. I've been in the Chef community the whole time. I work at OpsCode now, obviously. I did system administration for about 10 years, which meant I fixed broken things. I've worked in a lot of other areas, especially volunteer-wise. That's a picture of me somewhere in the desert solving traffic problems. You probably wouldn't know that the desert has traffic problems, but it does. So why did we need Chef? Who here considers themselves working in operations? Most of you? Responsible for servers? So originally, we need to build a new server. We get some new hardware, physical hardware that we're going to build on. We talked to someone about buying it. The vendor would build it for us. It would get shipped to us. It would get installed. The operating system would get installed on it. And finally, our software application would get installed. Depending on the size of your company, each of these steps could take weeks. They could involve other departments. It took a long time. So it really didn't matter that much how long application deployment took, because everything else was already taking us a couple months. With the introduction of cloud, and now we have these large internal clouds, virtualization systems, all those other steps are immediate. They just happen. You can have a new server ready for you in the cloud in 30 seconds. So now it really matters how fast we can deploy our applications. There's a number of good reasons for doing automation. These are a few of them. Makes things faster. When you look at the automation scripts, you can see what you're building. You can rebuild things. You can rebuild your entire infrastructure from your automation. Sometimes we're talking about Chef. All you need to rebuild your entire infrastructure is hardware, your Chef repository, and a backup of your data. And ideally, you should be able to do a complete disaster recovery from that. However, when I got into automation, the reasons that I got into it was because it meant that I didn't have to spend time in building servers anymore. And that was awesome. That was the really impressive selling point for me. This is Adam Jacob. He's a friend of mine. He's the original Chef developer. Adam has a saying that operations is responsible for two things. The first is availability. Are the servers that you manage up and running? If they are, great. The second is efficiency. Is it easy for people to use those servers to get their business work done? Because your job isn't really just building servers, it's helping the business make money or do whatever it's supposed to do. So Chef's a configuration management language. That's what most people think of when they think of Chef. We like to call it also a systems integration framework. You can manage more than just your servers with Chef. You can manage switches, you can manage load balancers. The idea is that you can bring everything together with Chef and be a central point so everything can talk to each other. And that's why we call it an API for your entire infrastructure. There's a term out there that's called infrastructure as code. And we want to be able to write everything that we need to rebuild our entire infrastructure as code so we can rebuild it easily. When we started Chef, we'd been using other configuration management tools, and we had some differing principles than they did, which was the reason we wrote Chef. The first principle of Chef is that it should be idempotent. Idempotency means that if something needs to be changed, it gets changed. And if it doesn't need to be changed, it's left alone. It's the if it's not broken, don't fix it thing. But it's really important in automation. Chef should be reasonable. So if you're running Chef on a Debian Linux machine, you expect it to use apt to install your packages. But if you're running it on a CentOS machine, you expect it to use yum instead. Chef has reasonable defaults whenever possible about how it makes its decisions, because we don't want it to surprise you. The core Chef language is primitives. This is like how many people consider themselves Unix people? A few? Most of you? All right. So in Unix, we have a lot of small tools, and we can put those tools together to build bigger things. Chef's built-in language is meant to do the same thing. The resources that we configure are primitives, and if you stack those primitives on each other, you can build bigger and bigger things. Chef should be scalable. That's a problem we had with other tools. We were building out these large, agile web startups that were just skyrocketing. They were Facebook applications that, ended up on a big website. Next day, there was hundreds of thousands of users that they need to scale immediately. And Chef should be hackable. Another problem we had with our other configuration management tools is they had an idea about how we should be building our infrastructure, and they didn't expect the kind of infrastructures we were building. So we wanted a tool that helped you do whatever you needed to do because you know your infrastructure best. And finally, Chef should be shareable. The cookbooks that Chef uses to configure your system were specifically designed such that you can write cookbooks that don't have your data tied into them. So you can share your cookbooks with other people, but just as importantly, other people can share your cookbooks with you. And we had problems with that in other tools we'd used previously. So this is a quick rundown of the different objects in Chef. And we have whole day classes on just this topic. So what I'm really hoping is that you'll walk out of here understanding what the different objects are, so that when you go to learn more about Chef, you can look up these objects and you'll have some idea of how they fit together. So Chef manages nodes. These are like servers, switches, load balancers, whatever you run Chef on. Nodes have attributes. Everything that we manage has information about it. We actually have a tool underneath Chef called Ohai that collects all kinds of information about your system and stores it as attributes. So you automatically have all this information available you can make decisions on. Like if you want to change how many services you run based on the amount of memory in your system, Chef already knows how much memory is in that system, and it can dynamically make that choice based on your code. Users and nodes authenticate to the Chef server as clients. Clients are an authentication object, while nodes are a data object. That's pretty important. To get work done, we write cookbooks. Cookbooks contain recipes. We take that joke really far. You'll find a lot of similarly named objects on the cooking theme. Each node in Chef has a run list. The run list are the things we want that node to do. The run list is a list of recipes. You can also have roles, so like a web server role, which can also contain a list of recipes. And this is where you start scaling your concept of what Chef's doing for you. You have roles for every type of server you have, and then you apply the roles to different servers. Rather than each server being a unique snowflake, you start thinking about, that's a web server, and if it goes down, I will build another web server, and it doesn't matter. I can replace that. Nodes can also be placed in environments. This is part of workflow. It's how you decide, well, these cookbooks are what I'm running in production. These cookbooks are what I'm running in staging, development. And finally, we have data bags, which data bags are named after bags. So this is a little bit of visualization. You can see from here that some of the concepts we just talked about. We have clients. The clients are the authenticator object. The nodes are what we're actually running. They can have run list. This run list contains a role. The role contains another run list which has recipes. In this example, we have two web servers which run Apache and PHP. And we also have a database server that's running MySQL and uses NFS for its data store. There's a man in our industry, his name's Andrew Clay Schaefer. He wrote the Meat Cloud Manifesto. This is part of this movement, of this agile movement in making things more automated. And one of the blockers to automation is we have all the software out there that's designed to be installed by a user. It's not designed to be automated. So it's really important in automation is that different pieces of software have an API so that you can use that to programmatically connect them together. So Chef was built on top of that idea. The Chef client is what you run on a server, a node, to actually make changes to that. Knife is our user tool. It's a command line tool you can use to talk to the Chef server to decide to create new roles, decide what recipes run on which servers. Chef shell, which in Chef 10, the command is actually S-H-E-L. S-H-E-F. Chef 11 is renamed to Chef shell because it's much easier to remember. Chef shell is this interface you can use for programming and debugging and figuring out what would work. You can run individual resources on a server. There's also Chef solo, which is a tool usually for standing up Chef servers is what we use it for. There are other companies, if you already have a way of getting your data around all your systems, there are companies like RightScale and EngineYard that use Chef solo underneath their existing infrastructure. But most people use the Chef client. Chef client is a client server model. There's a number of servers that the Chef client can talk to. There's the open source server. Opscode has a hosted solution and a private on-premise solution. And as far as Chef client's concerned, it's the same API, although the Opscode solutions have more endpoints. They have more features like role-based access control. This is a basic diagram of the Chef 10 open source server. There's a lot of moving parts in the Chef 10 server. Sometimes when people get into Chef, they try to build a server first. We recommend that people use hosted Chef first. Hosted Chef is free for up to 5 nodes. So when you want to get started with Chef, you can just use it as a server and start running clients and start figuring out how things work. As far as scalability goes, you can see in this, the places like the Chef server web UI and the Chef server API server. The idea is you can scale the Chef server out by just building more of those as your load increases. They keep talking to the same back-end server. Solar, up there on the right, is the search engine. We use Lucene. It doesn't really matter if you've used it before. It comes pretty quickly. So like when you run a Chef client run, it talks to the Chef server, save itself there. The Chef server puts that node objects in a queue, which then gets indexed by the search server, and then you can search for attributes on that server. So managing things with Chef. Chef manages resources. We have a package resource, a server resource. Resources have actions. So if you're installing a package, the package resource has an install action. That's what you want to do. These resources can also notify other resources. So like this is a resource that installs a file on a server. This is the Apache configuration file. And anytime we install this file, we also need to restart the Apache server, so it'll reload this file. So Chef uses that notification, that bottom line, to do that for you. Oh yeah, there's a laser pointer. What connects a resource to your individual system is a provider. Providers actually do the work. Of course, Chef runs on lots of different platforms, so the providers all connect to a different resource to do the work specifically on that platform. So on a Ubuntu system, the package resource uses apt. On a CentOS system, uses yum. Different service providers. There's sane defaults here, but you can override these. If for some reason you want to use a different provider than what's the default for that system, you can easily tell Chef to do so. And as I said before, that's something we very specifically wanted to let you do. This is what a Chef recipe looks like. This is a package resource telling us to install the Apache package. Here's a service resource. We want to enable the package. Enable means we want the package, we want that service to start on startup. Cookbook file resource is a resource that copies the file from the cookbook to the destination system. So here we're putting in the configuration file, and then we start the service now that the configuration file's there. There's different ways you can tune these resources. Resources themselves have attributes. For example, the service resource here, I've added the line to say that this service resource supports being restarted, reloaded, and checking its status. The service provider talks to different init systems, and some of the on Unix systems, and some of those init systems aren't very smart, so Chef has to make up for that. Like if you've used a regular init script that just came with a random piece of software, sometimes it doesn't have a restart command built into it. And Chef doesn't have a way of telling that automatically. Unfortunately, the init system's rather old. Other providers, service providers like Upstart, we know that has that functionality built in. You don't have to do something like that. And again, down there's a notification for restarting the service. Search is really important in Chef. This is one of the reasons we wrote Chef. We thought search should be built into Chef from the start. And part of the reason for this is we want to be able to dynamically build our infrastructure. And this is really important with Nagios. So search is a first-class citizen. It's built into Chef. We can search for all the nodes that are in a certain environment, that have certain tags, that have certain roles applied to them. And we can put search together with Ruby so that we can walk over that result. So we do a search, it returns 150 nodes. Well, now we can loop over those 150 nodes and do something to all of them. So like when we write a template, we can go and we can make a file that contains a line that says server, server A, server, server B, 100 times in this file. So if you have a configuration file that's just a list of all your servers, Chef can create that file automatically for you. So when you build a new server, you don't have to go edit that configuration file. And that's really important with Nagios because I've been in companies before where new servers get built and nobody takes the time to go and add them to the monitoring server, to the trending server. Everyone see that okay? Yeah? So this is a virtual machine I have on my system. It's just a basic Chef server. It's set up with a Chef environment already. The Chef server only has itself as a node. There's a few different clients. These are those authenticator objects. BTM is me, that's my user client. Chef demo server is the server itself. Validator is a special use case. We use it for creating new clients. And the Chef web UI is the actual web UI to connect to the API server. Like I said, the API was really important to us. So the web UI talks to the server the same way that all the other tools do. It's not built in. And we did that intentionally so that you could build other UIs on top of it. We've had people that built, there's a tool called Casserole. It was an OS X desktop application for managing Chef servers. You use the same UI. So I'm going to use the knife command line tool to go to the cookbook site, which is our community site where people share cookbooks. And I want to install the Nagios cookbook on my on my workstation here. So this is going out, it's connecting to our community site, it's downloading that cookbook. Chef cookbooks can have dependencies. So to run the Nagios cookbook, you also need the Apache cookbook or maybe the Nginx cookbook to have that web front end in front of it. And Chef knows this, so it's also downloading all the other cookbooks it needs from the server to be able to build this Nagios server. So now I have a number of cookbooks on my system. Now I need to upload those to my Chef server. They're just on my file system. I'm going to use a shortcut. Knife cookbook upload -a says to upload all of my cookbooks to the Chef server. Just do that rather than, you can say upload this cookbook and include all of its dependencies, or you could upload a cookbook at a time. If the server doesn't have the cookbooks it needs, it'll give you an error saying, hey, you upload this cookbook, but I don't have one of its dependencies. Doesn't all fit on the screen. I was talking earlier about these different objects. We send, because Chef has this API, we send data to it in this JSON format. JSON's just a data format for being able to easily move information through a web over HTTP. And so this is what a role looks like in the JSON format. There's a lot of information there. We won't go over it. But what I'm going to do is I'm going to upload that role to my Chef server. All right, so now my Chef server has a role called monitoring. And we can see down here that this run lists role contains the Nagios server recipe. I talked about data bags briefly. Data bags are a place where we can store data that doesn't necessarily belong to a single cookbook. Now, I've already read the documentation that comes with this Nagios cookbook, so I know that I need to create a user in a user's data bag with information, because Nagios needs users, it needs passwords, it needs email addresses. Those are going to be the same across all of our cookbooks. So we use this cookbook independent data bag to store this information. So similarly, that was in a JSON file I already created on my disk. So I've uploaded that to my Chef server. And that's what that data bag item looks like. A data bag contains items. This is the BTM user. I'm in the sysadmin group. I have a pre-encrypted, pre-hashed password in there, and some email addresses for Nagios to pick out of it. So our server's run list is currently empty. If we ran the Chef client, it wouldn't do anything. It would go and talk to the server, see that it didn't have anything to do, check in, and finish pretty quickly. But we want to build an Nagios server. So this command adds something to that node's run list, namely that monitoring role that we created a minute ago. Now I'm going to run the Chef client. So now the client's connecting to the Chef server, which happens to be on the same system. It's downloading all the cookbooks that it needs to build a Nagios server. It's going to start running those cookbooks, which also means it's going to install Apache based on some configuration already made. Again, having read the documentation for this cookbook, it's going to set up for HT-auth authentication to the Nagios server. There's a number of defaults it's going to do. I already downloaded all the packages to the archive on this system, so it shouldn't take that long. It won't be going out to the internet to get these packages, but it'll be installing them. And it'll take it a minute just to go through and install that package. The latest major release of Chef we just had has a new feature called the Y-run mode. You can run Chef in this Y-run mode, and it'll tell you what changes it would make to the system and why it would make those changes. Modeling a run like that is pretty complicated, so there's a bunch of discussion about that and when it's useful. But we could have run this in the Y-run mode, and it would have had a lot of output because there's a lot of things it's going to do. Chef actually made a lot of changes to our system right there. All right, so this is my demo server. It now has a Nagios server installed on it. It's currently monitoring just the Chef demo server. It's monitoring itself. But we want to monitor more than just this server. Unfortunately, I'm running on virtual machines on my system, so I don't have a lot of servers. But I came up with a way to create some fake servers. So we're going to create some fake servers. So we've created 5 fake servers. Now what I did is I actually told the Chef server that there are these 5 new fake servers. And I uploaded some basic information about it. So Chef right now, it saved those nodes to the Chef server. It went out and it notified the search server that there's some new servers indexed. The search servers indexed that and committed it. So now we can search for those servers as well. And this Nagios cookbook is search-based. So it's automatically going to search for all of the servers in our infrastructure as we've configured it. So I'm going to run Chef Client again on this server. And those searches are going to go out and they're going to find more information. So they're going to rewrite the Nagios configurations for us. And they're going to restart the Nagios server. So now we have 5 servers. Now I've pre-configured these servers. I actually have NRPE running on a VM in this, running multiple times on another VM to pretend to be these 5 servers. So these checks are actually real checks. They're going out. I've configured these servers. 3 of them, I told Nagios these are Linux machines. And so this Nagios cookbook automatically has some checks that will go out by default and look at on these machines. So it's already going out, checking the SSH is running on these machines, doing some regular checks. The other 2 fake servers I put in as Windows servers. There aren't default checks in this cookbook for Windows servers, so it's just doing a ping check. Based on search, this Nagios cookbook is automatically going to create host groups based on the roles that you have. So it found the monitoring role, which just has our demo server in it. It's also going to create host groups based on operating system. So here we have a host group based on, there's all of our Linux systems. And down below, there's one for all of the Windows systems as well. So that didn't take very long. And we also have, can show another feature of just this cookbook. Let's say that I wanted to create a new host group that was all of my HP hardware. For whatever reason, I need to just monitor that in its own host group. Well, because Chef collects this information about the system, it collects what's called the DMI information of a system. So it can tell from the BIOS who made the system. So we can go in and So I can run the search command and search my Chef server for all of the servers whose DMI system manufacturer is set to HP. Now I can have the Nagios cookbook do the same thing. Nagios cookbook supports creating dynamic searches from data bags. So create this Nagios host group data bag. And then I've also pre-created a data bag item. So this data bag item is specific to the Nagios cookbook, and it looks like this. This is just what we want to call the host group and the search that we want the Nagios cookbook to send to the Chef server to get the resulting nodes. So this is the same search that we just did on the command line. Run Chef client again. It's going to notice that there's this new data bag item. It's going to create that new host group. Again, it's just writing out new configuration files for the Nagios server. It's going to reload the Nagios server. If you look through all these output lines, you can see that there. The latest version of Chef also has some really nice new output formatters. Just while I know I don't particularly like that noisy output. There's the dock output formatter. It's hard on such a big screen to see the difference, but the minimal output formatter will be pretty obviously different. So you can tune all those things to what you like. If we go back to our Nagios server now, now we have this new host group called HP Systems. I happen to put my fake HP systems happen to be the same machines as my fake Linux machines. But so now it's monitoring those as well. All right, that's the demo. I'm sure that was incredibly fast, but can answer any questions.
Thanks. Hey, total chef noob. So do you have a recommended path for someone like me as a complete noob to follow to learn chef and then be able to actually use the cookbooks and recipes, etc., that you just showed us?
Yeah, so we have on the chef wiki, wiki.opscode.com, there's like it's either called a fast start guide or a quick start guide. They keep changing the names because of marketing reasons. But the path basically is you create a hosted chef account. Like I said, it's free. You have a chef server. And the hosted chef account will give you the configuration file you need on your machine to be able to set up Knife to talk to it, and the configuration file you need on your machine to have Chef Client talk to it. And then just do this on your workstation, and you run Chef Client. Of course, because you have no run list, Chef isn't going to do anything to your system. And so then your workstation's on there, and you can create some cookbooks that like create files in /temp, or like for me, like one of the tests I often do, I install Apache on my workstation and then like restart it and uninstall Apache when I'm testing Chef, because I'm not actually running Apache on my workstation, and it's fine to do that. So just do some things like that to start exercising it. Then we start putting Chef into your infrastructure. Pick off one thing that you need to rebuild anyway. Like for me, like when I first started doing configuration management, the goal was to put everything in it. But we started with something like putting NTP on a bunch of systems, or like configuring users on some systems, rather than jumping right in and deploying our entire application with it.
And after starting to learn Chef and getting your feet wet, I mean, how long do you think it'd really take? How much expertise would you need to be able to use those Nagios roles, cookbooks, etc.?
Well, this is actually really easy. Okay. I don't think it doesn't take that much. The Nagios cookbook README is really well written. It's maintained by a number of really great people in the community. I'd have to look at the Git log, but like 37 Signals has put work into it. WebTrends, a company I used to work for, is still using and put a bunch of work into it. And the documentation's pretty good. Okay. And so if you go and you look at the documentation, there's like a section about data bags for that cookbook. It's like, oh, if you create the Nagios host group data bag, it creates host groups. If you create this other type of data bag, it will create this. And of course, the goal here is that you don't want to relearn how to configure Nagios through Chef. You don't have to do it the same way. But the idea is that like you take the things that you're spending a lot of time doing and try to automate it using this. You don't necessarily have to use this cookbook to configure all of Nagios. There are different resources in there. Like I showed the cookbook file resource, which is a resource that just copies the file from the cookbook to the system. So you can start off configuring things by just taking the files you already have on the systems and just having Chef distribute them for you. And then you can move to a point where you have Chef start creating them dynamically as templates and then managing more and more of the system. But of course, there's benefits to just putting those in the cookbook, where you now have this central place, and you get rid of that situation where you have 10 web servers and they're all configured slightly differently, and someone goes in, makes a change on one, forgets to make it to all of them.
Thanks a lot.
Yep.
So if you're going to stand up some web servers with the Chef cookbooks, does the cookbook tie into automatically adding that into Nagios, or do you have to go to the Nagios cookbook and search for these new servers that have been created? And what about if you decommission servers? Is there a way to like automatically remove them from Nagios? Yeah. So again, Chef, you can do anything with Chef. So this cookbook in particular, what people usually do, what we actually currently do at Opscode, is in our production, we run Chef Client out of cron. It runs every like 15 minutes on our Nagios server. And it's all search-based. So this cookbook will start monitoring all of your servers by default. So as soon as you build a new web server, Chef Client runs again on your Nagios box, and it sees it. Unfortunately,
one of the things that, to make this more immediate, we need an API with the Nagios server where we can go in and when we run Chef on that web server, be able to hit that API and tell the Nagios server that we have a new node. But we don't have that yet. So we rely on running the Chef client on a regular basis. Removing it is the same sort of thing, where once you remove the node object from Chef, it'll no longer be returned in a search result. So the next time the Chef client runs on the Nagios server, it won't find that node anymore. It'll rebuild the config files without that node. What it actually does when it builds those config files is it builds them again on the side, and it compares the two. And if the ones it built are the same, it doesn't do anything. But if the ones it built are different, it puts the ones it just built over the top. So it's not actually removing anything from your config file as much as it's making a new one that has less stuff in it and putting it on top.
Any additional questions?
Saw Linux and Windows mentioned there. What about Unix? Any Unix flavors?
So we have people have run Chef on lots of different platforms. We also have what we call the omnibus installers. So these are a really great way to get Chef on a system, because what these do is they install into /opt, and they have Chef and they have Ruby. They have everything that Chef needs to run. So if you just want Chef on the system and you want isolated somewhere, you can use these, and it's just one command and installs. So we have omnibus installers for OS X. We have omnibus installers for Solaris, 9, 10, 11, x86, and Spark. What else? Different versions of Linux, Red Hat, derivatives. Somebody did a FreeBSD one. But Chef also runs on lots more platforms than that. That's just what we found a lot of people are using, so we've built Omnibus for those. I personally did a bunch of work getting on FreeBSD, which also works on NetBSD. The Solaris work, we've got the Joyent guys work with us closely, so SmartOS. There's some other derivatives there, OmniOS that it works on. Yeah. Just about anywhere you can get Ruby, someone's done it. I mean, we have switches that we run this on. So
Additional questions? All right, put your hands together for Bryan McLellan.